kills pests. The question was, what is a pesticide? Something that kills bugs, parasites, bugs, spray for bugs, bug spray, poisons. Yes, okay, so essentially a pesticide. Now, remember I told you that human beings, we need water, okay? And it is very important that we find ways of cleaning water for other human beings, because as I said, we've all got to live on this planet. Okay, but we also need food as well. Okay, we definitely need food. Now there are approaching 8 billion people. We're approaching 8 billion people on this planet, and that's a lot of people that have to be fed. Okay, so one of the ways we've been able to do that, to be able to feed enough people, is really, really intensive agriculture. And what that means essentially is growing very, very efficient crops, growing large amounts of crops, large amounts of food. The problem is that the plants that we eat and the plants that the animals that we eat, essentially those, they can be killed by little bugs, little organisms. They can be fed on by insects and pests, as we said. So essentially those pests, now those, we call them pests because they're real pests. The reason is they eat the plants, and they can kill the plants and things, which means there's less food for the human beings. So what we've been doing for a long time as a human race is adding pesticides. There are also fungicides, which gets rid of fungi, and also there are herbicides that get rid of other plants and things like that can compete with it. But essentially pesticides is essentially poison. Okay, it is a poison that kills these small bugs and things like that, okay? And these small insects. Okay, that's fine. So yeah, I mean, you know, it kills the bugs and things like that, which is more food. The problem is, if this poison can kill these small bugs, it might not necessarily be totally healthy for us. And even if it's not, even if it's safe for us, which some of them are, but they may not be healthy for other insects, other animals, things like that. And what will often happen actually is that, okay, perfect. I'm just double checking everything's okay. Yeah, perfect. Okay, good. What might happen is now what you can actually do is you can take these crops and you can wash them. Okay, so you can wash them off of these pesticides once you sort of harvest them. The problem is, where does that water go? And a lot of that water can go into lakes and rivers and things like that and kill the fish and animals and things that live around those. Also, the other problem, obviously, if it hasn't been washed properly or it somehow gets into the plant, we eat them, it's not so good for us. In fact, there is a chemical called DDT. Okay, D for dog, and T for turtle, so dog, turtle. But DDT, okay, that's not what it stands for. DDT is a chemical, okay, that is a pesticide, but it has been completely banned by the European Union. Okay, it is illegal to use DDT. Okay, and there are some other pesticides as well that are similar to DDT that have also been banned. Now, I do understand that there are some countries where it's not illegal. Some of these are not illegal. I'm pretty sure that you guys that the DDT is illegal in America too. Again, because it's so poisonous and it can kill obviously the animals and things like that and stuff, which is good that it has. But there are still some pesticides that are used. Now, obviously that's why people sometimes choose to spend a little bit more money and eat organic food and things like that. But as I said, as long as these chemicals are actually cleaned out of the water supply, that's good. So that is what activated carbon does. Now let me just quickly show you this, just so you can see. Now, as I said, the wonderful thing about these Wednesday sessions is because we only do one experiment, we can spend a little bit more time and go into sort of deeper into the science as we get to see those videos like with the activated carbon. I'm just going to quickly show you this. This is, now don't panic about it. It obviously looks quite complicated, but as I say, we're going a little bit deeper. What I'm going to do is show you this. Now this is a methylene blue. So this methylene blue, I'm going to show you what the molecule looks like. This is just an approximation of what the molecule looks like. Here at the top, that's this one here, okay? So, oh, there we go. Which way am I going? That's it. It's this one here, this top one here, okay? Now we can see, right, so that's the methylene blue. I'll put it back on in a second. But what you're looking out for is there are 2 hexagons. Okay, there's 2. Now, a hexagon is a 6-sided shape, so we can see the 2 6-sided shapes that are next to it with the joined in the middle there. But also look at the chemical below it. Now, the one below it is DDT. Okay, so the top one there is a molecule of the methylene blue, and the one below it is the DDT. Okay, so let's have a look at this. So this here is the methylene blue. Oh, sorry, there we go. This one's here's the methylene blue, and if we come down, this is the DDT. It also has that 6-sided shape, that hexagon there, okay? Now, they're not exactly the same, but they do behave in sort of similar ways. Now, remember, the methylene blue is not poisonous, but we, you know, I mean, I say we, with the MEL science people who send out the kits, there's no way they could actually put some poison in there, okay? This just, no, it's not a good idea. But we can use the methylene blue as a sort of a substitute for our pollutant. So that's what's going on in this experiment. The reason we are using methylene blue has very similar properties to a lot of these pesticides, by the way. And if it can, and what we found is, if you can clean out, if you can get rid of the methylene blue, you can also get rid of most of the, you can get rid of most of the, sorry, I was just reading hexagons there, but you can get rid of most of these pesticides, which is really, really good. So as I said, this isn't just important for cleaning water from things like human waste and stuff, but it's also really good to get rid of other molecules. Now, I just want to quickly point out that, so a question is often asked, basically, they were hexagons. Did I say pentagons and hexagons? Sorry, guys, if I said the 6-sided shapes, they were definitely 6-sided shape. I might have got it wrong. Sorry if I think I said hexagons, but you know. Now, essentially there, what's going on here is that I'm often asked, can we drink this? Okay, now the first thing I'm going to say is we do not drink anything within a chemistry laboratory or within a science laboratory, okay? The reason is there are possible other pollutants or other things in there. The problem is that I may have used my syringe here. I might have used my syringe for something else, okay? Like I know that I have been using sort of some acids and things like that, and it's possible that small amounts of that may still remain in there. The same thing also with the materials and things like that. That's why we never. Now, as I say, with the MEL Science kits, they do the best to make sure everything is sort of clean as possible, but as I said, that's why we still wear the goggles and the gloves, because within any science experiment there may be chemicals that may not be so good for us, okay? Now, methylene blue you do not drink, okay? Now this is it, but essentially yeah, and as I say, you should never be drinking any of these, okay? These, and they actually got warning signs on them, okay? All right, so as I say, don't drink anything, and actually another rule that I follow is, and Ali's really good about holding me to this, is I never drink anything or eat anything when we're doing science, so not even in close. So this here, you're in Ali and I's home, but it is separate from the kitchen part, and we make sure there's a real separation between the two, because it's just much safer that way. Okay, and yeah, you might be ill. But as I say, none of these are hugely toxic, the things you get, but not such a good idea to drink them. Okay, right, now, as I said, we talked about pesticides, and we want to get rid of those, okay? But what is activated carbon? This magic thing, we spent all this time talking about it. What is activated carbon? Okay, and I'm going to explain what it is. Now, activated carbon is actually made by heating carbon, okay? And mostly what we do is we get this from coconut shells. Wait, did he say coconut shells? Yes, coconut shells. Have you ever had coconut water? That is one of the main, now you can get it from lots of other places too, from wood and from twigs and things like that, but essentially the biggest source and one of the best source is from coconut shells. It's a very pure form of cellulose, okay? So essentially the coconut shells make a really, really good source. And also, what else do we do with the coconut shells? I mean, you know, I suppose you can make like horse hoof things, I suppose, and like little things you can hit together. But after a while, what else can we do with them? So essentially, they are really, really cool. Yes, yeah, from coconut, the ones that contain coconut water. Now, whether you like coconut water or not, it's still very useful. So these coconut shells, now what they do is it's superheated, and it's superheated with water vapor, and it actually reacts together. Now, how many of you guys, have any of you guys when you stay a bit long in the bath, or when you go swimming, or you've been in the sea and things like that, okay, what happens to your fingers and your hands? What happens? You know what happens? What happens when you've been in the water? Have you had that? Yeah, someone said shrivel up. They become pruny or wrinkly. That's right, wrinkly, absolutely, crinkles, raisin hands, crispy, absolutely they do. That's absolutely right. Now, there's nothing wrong with that, by the way. There's actually nothing wrong with that. In fact, that the body is doing that on purpose. Now, there's some evidence to say that it's possible that the reason the body does this is so that if you spend a lot of time in water, that it actually gives you better grip when you're underwater. Now, there's some conflicting ideas of whether this happens, but essentially it must have happened for some reason. Now, a similar thing happens. Now, it's not the same process. It's not the same process at all. But what happens if you heat up carbon, okay, within, so we take just normal carbon, so for example, coal, or, you know, sort of a, like kind of a, just lumps of carbon, and essentially if you heat it up, and from, as I say, all from the coconut shells, with a water vapor, it will react. It almost becomes more crinkly. Okay, so it actually starts to create little pores around it, which are little kind of holes around, essentially, and those holes are very, very good at absorbing things, these little wrinkles, okay, essentially, and the more you heat it, the more they have these tiny little holes, these tiny little pores, and that's what makes that's what activates it. It makes it incredibly good at absorbing. Now, the popcorn, of course, was sort of it had lots of shapes as well. It's quite good. It's no way as good as activated carbon, which is, by the way, incredible. And for its mass, it can hold a huge amount of toxins and things like that. So it is actually pretty magic. Now, carbon itself is pretty magic. So you heard, we were discussing at the beginning that Ali said that carbon is amazing. Carbon is incredible. Carbon is one, remember the, so those of you guys who've been to, you know, seen the show before know that, that around us all the time there are atoms. There are atoms all around us, and I'm made of atoms, you're made of atoms, the table's made of atoms. These atoms, now one type of atom is carbon atom, and it's incredible. So it makes this black sort of powder here, but also if it's combined in a different way, it actually makes the graphite, which is what we have in pencils. Okay, and that's pretty incredible because it's a non-metal, but it can still conduct electricity. It's kind of magic. But one of the most amazing things that carbon does, which I think is absolutely incredible, is if you compress this carbon with enough heat and pressure, and by the way, it's more than we can do ourselves. It happens deep inside the earth, but we've now built machines that can do it. You can actually turn them into diamonds. Say what? Yes. Diamonds are actually made of compressed carbon. Now, what actually happens is this. Imagine Owly, okay, here's Owly, and you have lots of people standing in a room in front of Owly, okay? He might, if there's enough people, he might not be able to see to the other side of the room. I know, you can't see the other side of the room, okay? So we have lots of people there. But if we got everyone to line up in regular rows, you know, kind of like soldiers rolling up in rows, if he walks down, we can actually see down the rows, and he'll be able to see down to the other side of the room. And that's exactly what's happening in carbon. Well, I say exactly, it's an approximation, but essentially what's actually happening is the atoms are lining up in perfect rows, and what that does is it allows light to travel through, which is just incredible. So if you think of a lump of coal, that could be turned into diamond. So cool. So cool. Now, carbon does amazing other things. Now, one of the things that it does also is you can actually make carbon nanotubes, and there are some incredible things that you can do with carbon. Now, I'm going to just quickly ask Ali. Ali, what is it that I wanted to be when I grew up? Like, when I grew up, when I was a kid, what is it that I really wanted to be? Because he's been with me, remember, since I was a baby. So what is it that I really wanted to be? Okay, yeah, an astronaut. That's true, actually. I did want to be an astronaut. But what was the other thing that I wanted to be? Like, what was I really like I wanted to be if I couldn't be an astronaut? Yeah, an inventor. I definitely want to be an inventor. And that's the thing about inventing, is I always saw inventors as being sort of like, I see some people guess engineers, inventors being sort of people who kind of put stuff together and make robots and other fun stuff. And that is true, that's a little part of it. But the modern day inventors, the really incredible inventors who are doing really life-changing stuff, are actually working with individual atoms and groups of atoms and molecules of these atoms to create amazing structures. And by the way, just activating the carbon, right, makes it amazing. You saw how it took away that gas, which I thought was absolutely incredible. And in the same way, we can do that with lots of other types of molecules, and we're discovering some amazing properties of those. A wonderful one that we know of is that it's space. Now, I don't know if any of you guys watched the SpaceX launch, the NASA SpaceX launch the other day. That was incredible. But I have to tell you, it still costs millions and millions to get astronauts into space. It is so expensive. And one of the designs that that humans are looking at is some kind of space elevator that literally would be an elevator that actually goes up into outer space. The problem we've got is being able to create some form of cable that would be strong enough to hold its own weight. And one of the ways we're looking is using carbon to build these amazing nanotubes to do that. Now that is a really, really cool invention. That's what modern day inventors are doing. So if any of you guys do decide to go on and become scientists or anything like that, now remember, you don't have to actually do it as a job to be a scientist. Science is really about being inquisitive and wanting to learn about the world around you, you know, and really the quest for knowledge, okay? So if you guys want to do that, there's some wonderful areas that we are just beginning. I think one of those ideas is everything that's ever been invented, you know, everything that's going to be invented has been invented already. No. I think we are now at the beginning of an incredible age where we are taking things like normal just carbon and we're making wonderful stuff. And I have to say there is some incredible discoveries to be had. And I'm really excited to see what you guys come up with. Now, we are sort of coming towards the end of our time, basically. If you're interested in carbon and the way it bonds and things like that and why it makes statements so hard, you can have a look online. There's some wonderful videos about it as well. And I think at some point maybe we'll do an entire, I'd love to do a session on carbon because there's so many cool things we could do with it. But this is one of the really cool ones. And look at this, we've been able to create this water here. Now I have to say, just careful, the reason we don't drink this is because there are lots of processes involved in cleaning the water for our drink supply. One of those is heavy metals, things like lead and mercury and things like that can somehow get into water. Now in order to clean those out, we use ion exchange, and there is another set in the pure water set that does that. You can actually build your own ion exchange there. But yeah, look, I just wanted to make sure we kind of went through it, went a little bit deeper. That's what's wonderful about these Wednesday sessions. Ali and I are fully aware that you guys could be doing lots of other things with your Wednesday, but today we got to see some water clean. We also got to see, isn't that incredible? Do you remember the gas, the nitrogen dioxide, where it got sucked into, and also the popcorn? How cool is that? So, as I said, yeah, you love carbon, don't you? You love this one. So it's been so nice to have you guys here. Thank you so much. I was fully aware you could be doing lots of other things with your time. Thank you for joining us in our home in London. And yeah, also with this Wednesday session, just to go a little bit deeper into the science. Remember, all the other days of the week, we've got lots of cool DIYs ones. I'll be back next week anyway. My friend Dan obviously is around and things like that. We're doing some great stuff this week. So keep tuning in. Invite your friends as well if you think they'd be interested. And yeah, make sure you post #MELScience or email us your pictures and things at melacademy@melscience.com. So nice to see you all. And thank you to Kat as well in the chat. And bye, guys. I hope you have a lovely rest of your week. Take care, and we'll see you soon. Bye from Owly. Bye from me. Bye-bye.